The Align tool has new features that give versatility when aligning two surfaces. You can see I have two very different surfaces in terms of their overall form and size. This could make it very difficult to join these two shapes. For instance, to join these two surfaces, I would have to work out the transition surface that takes into account the flatness of one surface and the more shapely form of the other surface. The Align tool can be found in the palette under the Object Edit tab. When I join these surfaces using the positional setting, I now have the option of using positional influence. Positional influence gives me the capability to adjust the way the input surface connects with the master surface at the point of the positional alignment. In other words, positional influence only affects the CVs in the positional row of the input surface and tries to better fit the positional alignment. I have the option of sliding the setting from 0, which is the default, and maintains the surface parameterization as best as possible, or as you can see, the closer I get to 1, the more the alignment attempts to match the parameterization of the master surface. Here there is a slight movement of the positional CVs as I move closer to 1. Moving on to tangency and curvature continuity settings, you will notice an option called tangent balance appears, but only when both are surfaces, you are aligning to a natural boundary, and both outer edges are set to edge align. Tangent balance adjusts the lengths of the input surface to match those of the master surface. This condition applies for both tangency and curvature continuity settings. In this case, the right surface is the input surface, and the left surface is the master surface. The adjustment arrows located outside the center arrows are no longer available. You now can adjust the entire surface continuity and have the outer edges of the surface match the continuity of the master surface. However, tangent balance locks out the first row or tangency row of CVs to retain the parameterization of the alignment. The Align tool now has explicit control, so you can add information to the input surface as needed. In this case, I have two simple surfaces. On the input surface, I can turn on explicit control and manipulate the amount of information the surface contains. Maybe I want to match the master surface better, or need more information on the input surface so the remainder of the surface isn't affected by the alignment so drastically. In any case, I can adjust the degree or spans of the input surface by turning on the explicit control. I can take a more metered approach to visually adjust the tangency and curvature rows by using the sliders provided in the option box of the Align tool. Here I can move the slider for tangency scale to further manipulate the surface. I have individual control over the start and end adjustments, therefore adjusting each individually to meet the needs of my current project. As always, I can type in the value to make a precision adjustment to the input surface. This holds true for both tangency scale and curvature scale. One thing to note, the numbers are in true lengths, expressed here in centimeters rather than scale factors. Turning on Skew gives the alignment tool the ability to rotate the CVs and ultimately the input edge shape by clicking and dragging on the blue skew arrows. They turn yellow when they are active. When I have two surfaces that are not the same as far as width that need to be aligned, I can still complete a partial alignment. Although partial alignment is turned off by default, turning it on will align the input edge to the closest points on the master surface. To further tweak the alignment, I can grab the start and end arrows and slide them across the master's edge. Using the arrows gives you additional freedom when aligning one surface to another. In addition, I can also use the sliders to create a partial alignment and control the endpoints of the input surface.